Okay, this is the second part of the 6.4 notes, and here's example number 3. This is a long problem, but it's all very doable. ABC has vertices -4, 1, 8, -1, and -2, 9, and DE is the midsegment. We don't really know where DE is, but we could see they want us to find the coordinates of D and E. They want us to verify that AC is parallel to DE, so that gives us a clue of where this midsegment is. It should be parallel to AC. And then they want us to verify that DE is exactly half the length of AC. Okay. So we need to plot all these points. So I'm going to do blue. A is at -4, +1, so that would be right here. Okay. B is at 8, -1, so that would be right there. Did I count that right? Yeah. And I'll just put a little B, 8, -1. And then C is up here at -2, 9, so I'll go up 4, 5, 6, 7, 8, 9. I'm going to recount that just to make sure. 3, 3, 3, yep. So that's C, and we said that's -2, 9. And now what we want to do is we want to draw a straight line, connecting all these things. Kind of hard for me to draw a straight line on the iPad, but okay. It's close. It's not right on, but it'll work for the sake of this lesson here. And we want to find the midpoint. And remember, we said the midpoint has to be parallel to AC here. So the midsegment is going to be somewhere right here. But we need to find the exact coordinates of the endpoints of the midsegments, the points that hit here and here. Well, in order to do that, we just need to find the midpoints along this line and the midpoints along this line. And this is actually way easier than you think. It's something we could even just do in our heads. Because all we're going to do is we're going to just take our x values of C and B and add them up. Well, I got -2 and I got 8. Added together, that's +6. Then you take those numbers divided by 2. 6 divided by 2 is 3. So our x coordinates are 3. And I've done this problem before, so I know that it's actually supposed to be 3, 4. I'll show you why in just a second. But I'm going to mark it right here. Okay, and we'll call that point E. And I said the x value is 3. Let me show you why it's 4. Take 9, -1, add it together, you get 8. 8 divided by 2 is 4. So there we go. So we're going to do the same thing over here, A to B. I got -4 in the x, +8. 8 and -4 make 4. 4 divided by 2 is 2. So it's going to be at x equals 2. And then I know that it's 0 also because I got a 1 and a -1. And 1 and -1 obviously make 0, and 0 divided by 2 is 0. So here's point D at 2, 0. So there's our midsegment right there. Okay. Well, now let's see what else they want us to do. We found the coordinates of D and E, and now we want to verify that AC is parallel to DE. So we want to verify that these two lines are parallel. Well, some of you guys may have forgotten, but the way we verify that things are parallel is their slopes have to be equal. So we're going to just find the slope of AC here, and we're going to find the slope of DE. So let me zoom in a bit. Actually, you know what? Let me write up here what the slope formula is, just in case you forgot it. But slope will equal y2 minus y1 over x2 minus x1. And also, in a second we're going to use the distance formula, so I'm going to write that up here. x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. Okay. So let's do slope first. I got these coordinates in, so I'm going to just zoom in so I have enough room to write everything. But if I want to find the slope of AC, I'm going to take my y's, which if I look over here, I have a 9 and a 1 in my y. So I'm just going to do 9 minus 1. and my x's. So I'm going to do negative 2 minus negative 4. Okay, well, whenever I have a double negative, like I do right here, it just turns into a positive. And so I got 9 minus 1, which is 8, and negative 2 plus 4, which is 2, and 8 divided by 2 is 4. Okay, now I'm going to do the slope of the mid-segment, so the slope of DE. And I'm going to do basically the same thing. Take my y's, 4 minus 0, which I could pretty much just do in my head, right? It's just 4. And then take my x's, which is 3 minus 2, which I can also do in my head, just 1. 4 divided by 1 is 4. So these slopes are equal. So yes, they are in fact parallel. So we found the coordinates of D and E, we verified that AC is parallel to DE, and now we are going to verify that DE is half the length of AC. Well, let's do that by using the distance formula. We need to figure out what each of these distances are. So let's first find the distance of AC. AC equals, and we're going to do x2 minus x1. Well, I have the coordinates right here, if you remember, right? So it was negative 2 minus a negative, which made it plus 4 squared, plus 9 minus 1 squared. Negative 2 and positive 4 make a 2 squared, and 9 minus 1 make a 8 squared, which is the same thing as 4 plus 64, so square root 68. Alright, I'm going to come back to that in a second. Now let's do the distance of DE. Same idea, take my x's, 3 minus 2. This should be pretty easy. 3 minus 2 squared, that's just going to be 1 squared, so that's just going to be 1. And then add to it my y's, right? So 4 minus 0. Well, again, we just have 4 minus 0 squared. Well, 4 minus 0 is 4, and 4 squared is just 16. So we get that this is rad 17. Now, at first look, this does not look like it is twice this, but I'm going to show you that it is algebraically, and then I'm going to tell you to do this. You can just take this number, put it in your calculator, multiply it by 1/2, and see if it's the same thing as this. But let me prove to you that this number is exactly twice this number, and I'm going to do it algebraically. I did not do this in class, but could be helpful, I think. Okay, so we have square root 68. Well, remember when we have square roots, we can break it down a little bit. So let's break it down. What's a number I can pull out of 68? Well, I can pull a 2 out of 68. If I divide 68 by 2, I get 34. So 2 and 34. All right, well, I could pull another 2 out. Well, then I get 2 and 17. So I could rewrite this square root. I could say that rad 68 equals 2 squared times 17. Well, since this 2 is being squared and it's underneath the radical, I can also just bring it outside the radical and put 2 rad 17. And look, sure enough, rad 68 is actually twice rad 17. And if you don't believe me, if this didn't really make sense, just plug that in your calculator and multiply by 1/2, and then plug this in your calculator and see if those things are the same thing. Or you can plug this in your calculator and multiply it by 2, double it, and see if it's the same thing as rad 68. But it is, and I win. Okay, this last one is pretty quick. It's just basically what it's saying. Well, let me read it for you, and I'll summarize for it. It just says, hey, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if you have parallel lines, and you have any segment or any line going through them where it makes lines congruent, so we know that AB is congruent to BC. If that's the case, then that means no matter what other line goes through here, it doesn't matter what angle or what, any lines going through here are always going to make congruent segments. So that is enough to know that DE and EF are congruent. And if you look at this problem, they tell us that AB and BC are congruent, so we're going to solve for x. Well, these things have to be congruent as well. So we just take 3x minus 4 and set it equal to 6 minus 2x. And that's it. Just do some algebra. Add 2x to both sides. Add 4 to both sides. These things cancel. These things cancel. 3x plus 2x is 5x. 6 plus 4 is 10. Divide both sides by 5 and you get x equals 2. And then if you wanted to find df, you could just go ahead and plug it back into both of these because df is the total distance. So there's a few ways you can do that. Since you know they're congruent, you can plug it into one and double it. Or you could just plug them into both, added together. So let's do that. Okay, so DE is 3, and instead of x, I'm going to put a 2 minus 4, and then EF is 6 minus 2. Instead of an x, I'm going to put a 2. Okay, so 3 times 2 is 6, minus 4 plus 6. 2 times 2 is 4. 6 minus 4 is 2, plus 6 minus 4 is 2, so we know that DF equals 4. Okay. Summary, explain the difference between a midsegment and a midpoint. Let you guys do that on your own. Not a very hard summary, but there you go. That's it. Adios.